Alright, so hopefully this is a review, exponent properties. So we have a couple different rules here, actually quite a few different rules here. 7 to be exact. Okay, so a couple of these are the same, but first property, first rule, exponent of 0. Okay, so exponent of 0, basically anytime you have an exponent of 0, and again, the a, or the base number, the big number, can't be 0. Okay, so the base number is any number or any variable where x is not 0 in that case. But this is going to be equal to 1. Okay, so for instance, and you'll see it down here later on. We'll talk about it. We'll come back to number 1 here. But anytime exponent is 0, so x to the 0 power 1. Now remember, here's kind of what we've got to remember. The exponent only acts on what's directly in front. Okay? So in this case, the exponent of 0 only acts on that x. So that x is 1, and then 3 times 1 gives me 3 in that case. Now, it's a 3. Sorry, it's not a very good one. Okay. We're going to come back to this D. Okay. We're going to come back to this D here in a minute. Okay. Yeah. And so this gives you an error message when you type it in the calculator. So if you type that in Desmos or whatever, or in the calculator, it should give you an error message. Okay. But we'll come back to that here in a minute. Of why. Alright, so rule number 2, negative exponents. So if we have negative exponents, basically you're moving it, okay, in the fraction. So if it's a whole number, remember, it's always over 1, so I'm going to take it and I'm going to move it in the fraction to the bottom, if it's in the top. If it's in the bottom, I'm going to move it to the top. And that exponent then becomes positive. Okay? So when I look here at number 1, x to the negative third. Again, this is all over 1. So I'm going to take that negative exponent, move it to the bottom. 1 over x, and it becomes positive. 1 over x to the third. Again, this is over 1, so 5 to the negative second, moving it to the bottom. So we have 1 over 5 squared. And 5 squared is what? 5 times 5 is 25, so 1 over 25. So if I have a negative exponent in the bottom of the fraction, denominator of the fraction, again, I'm just moving it to the other side. So I'm going to move it to the top. So this then becomes y to the 5th. If you put it over 1, not a big deal, but you don't need that over 1. Okay, so if there's nothing else in the bottom, once I move it, you don't need the bottom. It just becomes a whole number. And then the last one here, letter D. Again, we're taking the 2 to the negative third, moving it to the top. So the 5 stays, bringing up the 2 to the third. 2 to the third is what? 2 times 2 is what? 4 times 2 is 8, so 2 to the third is 8, so 5 times 8 gives me 40. Okay, so that's negative exponents. Move it in the fraction, one side or the other. Okay, if it's in top, move it to the bottom. If it's in the bottom, move it to the top and make it positive. The rest of these rely on same base. Okay, so the big number, the base number has to be the same. The variable has to be the same, or the number has to be the same. So if I have, and I'm multiplying two values with same base, okay, so if I look here at letter A, x to the third, well, x to the third is x times x times x, right? X squared is x times x. So again, this is all just being multiplied together. So how many x's am I multiplying? Here I have 3, here I have 2, so a total of x to the 5th. I'm just adding those exponents together. Okay? So 3 plus 2 gives me 5, x to the 5th. In B, most of the time, this 1 will not be there. Okay? It's still there though. So when I have 3 times 3 to the 3rd, well, I still have those exponents. This is a 1 plus 3, which gives me a 3 to the 4th. And again, if I plug that in the calculator or multiply it out, I think I get 81. Same thing applies if I have negative exponents. Still going to do the same operation. So here I have multiplication. So again, I'm just going to add those exponents. So negative 2 plus 3 gives me positive 1. Again, I don't really need to write it. So just a y. And then letter D, 2 to the 3rd and 2 to the negative 4th, again adding those exponents. So 3 plus negative 4 gives me negative 1. So 2 to the negative 1. No negative exponents. So again, move it to the bottom. So 1 over 2 to the 1st power, or just 1/2. Okay, so that's multiplying, same base. Dividing, same base. So dividing same base, so kind of a big scale of it, idea is x to the 7th, 7 x's, 3, 4, 5, 6, 7, divided by x to the 5th, 5 x's, 1, 2, 3, 4, 5. Now, what is x divided by x? What do I get? If I take two numbers and divide it by the same, 5 divided by 5 is what? 1. So x divided by x is 1. So that becomes a 1, 1, 1, 1, 1. So the 5 on the bottom match up with the 5 on top. Those all become 1. And what's left over? 2 x's. So x squared. So again, we're just take those exponents, shortcut, we just subtract them. Top number divided by, or top number minus the bottom number. Okay, so 7 minus 5, 2. So same basis, so base is 5. 2 minus 4 gives me negative 2. Again, no negative exponents, so we're going to move it to the bottom. So 1 over 5 squared is what? What's 5 times 5? So 1 over 5 squared, which is 25, 1 over 25. So here I have my y's. 3 minus negative 2. Minus negative becomes what? Plus. So 3 plus 2 gives me 5. So y to the 5th. And in D, if I just have a number, nothing underneath it, I can just rewrite it. So the 2 looks like 2 divided by 1. X to the 3rd over x squared. So 3 minus 2 gives me x to the 3 minus 2. 1. So x to the 1st, so just 2x is my answer then. Alright, number 5, rule 5 here. So again, exponent acts directly what's in front of it. So in this case, it's the set of parentheses. Okay, so here I have x to the 3rd, or xy in parentheses to the 3rd. So I have three sets of parentheses. 1, 2, 3. What's in each one? Well, each set of parentheses contains an xy. So xy, xy, xy. So in the end, how many x's do I have? 3. How many y's do I have? 3. So this exponent, kind of like we say distribute, gets distributed to each other exponent in there. So again, x to the first, 1 times 3, 3. Y to the first, 1 times 3, y to the third. Okay? So that exponent on the outside of the parenthesis goes to everything on the inside. So in B, this 2 goes to the 5, so I have 5 squared. And the 2 goes to the x, which gives me x squared. 5 squared then again is 25. So 25x squared. This is my answer. So going back, negative exponents. So the negative again moves it to the bottom. So it's going to move everything in the anything in the parentheses to the bottom. So 1 over everything in the parentheses goes to the bottom. So 2 to the third and y to the third. Now 2 to the third is 8. So you could simplify that down to 1 over 8y to the third. And then 0 exponents. Anything with an exponent of 0 is what? Nope. If I have a number to the 0 exponent, it's going to give us what? Nope. 1. Anything to a 0 exponent's 1. Okay? Assuming it's not 0. Okay? 0 to the 0 exponent gives you that error. Everything else gives you a 1. So number 6 is just kind of like what we did here in number 5. It's just division. But again, the number outside the parenthesis goes to both top and bottom. Okay? So just remember, if I have parentheses, everything in the set of parentheses gets the exponent. Okay? You don't really have to remember 2 different rules. Okay? So when I look at this, it's the same idea. I have 3 sets of parentheses, but in this case I have an x on top and a y on the bottom. So now, same thing. X to the third, y to the third. Both parts get the exponent. Same thing in B. If I have numbers, 1 squared, 3 squared. And again, I can simplify that down to 1 and 9, 1/9. Negative exponents. So if I have a negative exponent, again, if you want to write it out, you can. So I have x to the negative second, 5 to the negative second, and then the negatives move to the other side, right? So the 5 goes on top, so 5 squared, or 25, goes on top. X squared moves down to the bottom. Okay. So basically, if you have a fraction, you can just flip it if you want to get your answer. Okay. I would typically just flip it and not rewrite it out like I did here. Okay. But I wanted to show you that's the negative 2 goes to both, and then you're going to move them both so they just flip. So in D, same idea, flipping it. So the y goes to the top, so now y to the third on top. Negative 6 to the third on the bottom. So again, it's important when that negative's in the parentheses, okay, that you keep it in there. In this case, it doesn't matter as much because it's the third power. But when I simplify that down, 6 to the third gives me 216. So then y to the third over negative 216. And the last rule, power of a power. So here I have exponent inside the parentheses with an exponent outside the parentheses. So what happens is I'm just multiplying those together. Okay? So same kind of like what we did up here, except for these were just ones. Now we're going to actually multiply these together. So 2 times 3, x to the 6th. Multiply my exponents together. 2 times 5, 10. 2 to the 10th. Even if my number doesn't have an exponent, it has a 1, right? So it becomes 5 squared. And then to the y, 3 times 2 gives me 6. And then you could simplify this down to 25. Y to the 6th if you wanted. And then negative exponent, again, you can just move it straight to the bottom if you'd like. So 1 over 3 times 5 is 15, so g to the 15th. So any questions on the properties here? So I forgot to go ahead and go back to it. So think about, so why is this an error? Okay, so if we go back to number 4, okay, fraction dividing. So if I have, let's say I have x to the third over x to the third. Well, if I subtract those, 3 minus 3 gives me what? X to the 0, right? So that's why it ends up being 1. Okay? So mathematically, if I have 3 x's on top, 3 x's on the bottom, they all cancel out with each other, which leaves me with x to the 0 when I subtract. So that gives us a 1. Okay? Now, if it's a 0, can I divide by 0? Yeah. Right? Because if I have, let's say I have 5 divided by 0, is that going to get me a number? No, because remember, this is like saying 0 times what equals 5. Well, I can't multiply anything times 0 to get 5, right? Because no matter what I multiply by, I get 0. So I can't divide by 0. So that's why this ends up being an error message. Because it's like saying 0's in the bottom of that fraction. Does that make sense? Okay. So flip it over on the back. We got a couple problems to work here on the back. A little bit bigger, but not much harder than what we just did. So looking at number 1, if I have all multiplication, we can rearrange the order of multiplication, right? So if I want to take 6 times 2 times x to the third times x to the 5th and rewrite it, I can. Now, I'm not necessarily going to do that. If you want to do that, you can. Okay? But that's my philosophy. I'm taking my numbers and I'm multiplying them together. So 6 times 2 is 12. X to the third times x to the 5th. Same base, multiplying, add the exponents. So 5 plus 3 gives me x to the 8th. So 12x to the 8th, and I'm done. Okay? So that's kind of the process I'm looking at. I'm looking at my numbers first, multiplying them together, or dividing them when I get down here to the bottom 3. And then I'm combining my exponents that are the same base and using the rules there. So number 2, again, everything's being multiplied. So I'm looking at my numbers first. So negative 3 times 4. Negative 3 times 4 is negative 12. Now I'm going to look at my m's. Again, multiplying. So 5 plus 3 gives me m to the 8th. And then I'm going to look at my p's. Again, remember there's a 1 here. So 1 plus 4 gives me p to the 5th. and I'm done. So number 3, we have power to a power. So again, everything inside the parentheses gets this exponent of 3. So I have 4 to the third, and again, if I want to simplify that right away, I can. So 4 to the third gives me 64. 3 goes to the 2, so G, 2 times 3 is 6. H, 3 times 5 is 15. 64, G to the 6, H to the 15. Okay. The other type problems you can have would be division type problems. So just like up here, when I had big numbers, okay, not exponents, I'm multiplying them. Same thing here. If I have big numbers, 18 and 6, what's 18 divided by 6? What's 18 divided by 6? 3. Same type of process. Looking at my big numbers first. Now I'm going to combine my A's. So A to the 7th over A to the 3rd. So 7 minus 3 gives me A to the 4th. It's positive. It's on top. B to the 3rd over B. So 3 minus 1 gives me B second. And C to the 5th and C to the 5th. So 5 minus 5 gives me C to the 0, which is just a 1, and I don't have to write it. So 3, A to the 4th, B squared. Now number 5, does 3 divide by 9? Does 9 go into 3? No. But I can simplify. Okay? So just like your normal fractions, if I had 3/9, well 9 is 3 times 3, right? So this 3 on top cancels with one of the 3's on the bottom. So really I have a 3 in the bottom of that fraction, right? So now I'm going to look at my letters, my variables. So m first, so m to the 7th and m to the 1st. So 7 minus 1 gives me m to the 6th. It goes on top because it's positive. And then my p's, p to the 5th, p squared, so 5 minus 2 gives me p to the 3rd. And I'm done. And last one, 16 divided by 8. 2. So A's, A to the 7th over A to the 3rd, so 7 minus 3 gives me A to the 4th. Looking at my B's, B to the 0 is 1, right? Since I have something here, I'm just going to cross it out. Okay? If I don't have anything, I'd put the 1 in there as a value. But anything times 1 is what I have, right? So I don't need it. And then C to the 5th over C squared, 5 minus 2, C to the 3rd. And I'm done. Okay? So, rule of thumb and simplifying. Okay? No negative exponents. And no 0 exponents. Okay? So no negative exponents, no 0 exponents with your variables. Okay?